This is video part 2 of the two-part video series on Archimedes principle. I recommend you to watch part 1 before watching this video for a complete understanding of the concept. In the last video, we talked about the first statement, that was, when a body is immersed fully in water, it experiences an upward force. In this video, we will take a look at the second statement of Archimedes principle. Remember when you were in primary school, you must have heard or read a fable about the crow and the pitcher, in which a thirsty crow finds a jug of water. It wanted to drink the water from the jug, but the level of the water was so low that it couldn't reach it. So the crow started picking up pebbles one by one and kept on dropping them into the jug. With the result, the pebbles raised the water level. The crow happily bent down, quenched his thirst, and flew away. What a super smart crow! This is a perfect example of the second statement of Archimedes' principle, which reads, the upward force is equal to the fluid displaced by it. Keeping this story in mind, let's do an activity to prove this statement. This is the same bucket that I used before. I am immersing it in the water. As you can see, the water is flowing out of the bucket. What it means is that it's getting displaced. How much water did our object displace? Let's measure it. This is a measuring cylinder and it can measure up to 500 ml, that is half a liter. I'm going to pour this displaced water into the cylinder. And this is exactly 500 ml. So let's empty this cylinder. There is still some water left and pour the remaining water in it. And this is also 500 ml. So the total water displaced by our object is 500 ml before, and this 500 ml, that is 1000 ml or 1 liter. Now let's find out the weight of this 1 liter water. I'm going to use the spring balance again. Okay, so the amount of water displaced by our object was 1 liter. As you can see it, it's exactly 1 liter. Now we have to weigh and see how much our 1 liter water weighs. So this is our spring balance and it's already calibrated at 0 kilogram. And now I'm going to pour this water in here. And if you look closely, it's approximately, or rather it's exactly 1 kilogram, or maybe there might be a little error. So the weight of 1 liter water that was displaced by our object is 1 kilogram. So the question is, how could the buoyant force be written mathematically and how could it be calculated? As you have learned from my previous video that the tension force T is equal to mg. Mg is, m stands for mass and g is the gravitational acceleration. You also learned that apparent weight is mg minus bf. So how do we calculate bf? Bf, you know, is the weight of the displaced liquid. You have read before that weight is equal to mass times gravitational acceleration, that is W is equal to mg. This is a little formula triangle. A very simple way to remember. If you want to find out the density, you have to divide mass by volume. If you want to find out volume, you have to divide mass by density. And if you have to find out mass, it's density times volume. So in our case, density will be mass over volume, or rho is equal to mv. Rho is a symbol used for density. So m will be equal to m equal to rho times v, that is density times volume. Thus, mathematically, BF can be written as FB, which is a symbol for buoyant force, equal to rho Vg. So this is the formula for Archimedes' principle, that is FB equal to rho GV. Now there's a little chart. On one side you see the symbols and the other side you see the units. So the first one is FB, which stands for buoyant force, and the unit for buoyant force is Newton. Second is rho, that is density of the liquid, which in our case it's water, which is 1000 kilogram per meter cube or 1 gram per centimeter cube. Number 3 is V. V is the volume of the fluid. Again, our fluid is water, which is 1 liter. And 1 liter, as you know, equals to 0.001 meter cube. And the last one is G, acceleration due to gravity, and of course the value of it is 9.8 meter per second square, which is a constant value. So let's plug in all the readings that we recorded from our activity in the formula given. And what was the formula again? FB is equal to rho GV. So FB is 1000 kilogram per meter cube times 9.8 meter per second square, which is the acceleration due to gravity, times 0.001 meter cube, that's volume. And if you multiply all these numbers, you will come up with 9.8 N, that is 9.8 Newton. This, in our case, is the buoyant force of our object, that is 9.8 N. Now, according to the second statement, the buoyant force must be equal to the weight of the water displaced. So this 9.8 N should be equal to 1 kg of water. So how do we do that? To find out whether it's equal, we have to convert the buoyant force, which is in Newton, into weight. You know the force is equal to mass multiplied by acceleration due to gravity, that is F is equal to mg. Here our F is 9.8, which you already calculated. G is 9.8 meter per second square, that we already know is a constant value, and M is what we want to find out. So if we plug in all this information in F is equal to mg, we get 9.8 N equals to M times 9.8 meter per second square. So M will be equal to G over F, which will be 9.8 meter per second square over 9.8 Newton. And if you divide this, you get 1. So this M is equal to mg. It is in kg because we have used SI unit. So BF is equal to 1 kg. This matches our reading that we got from our activity. Now let's look into the weight of the volume of water displaced by the object. So the volume of the water displaced is 1 liter, as we measured before. We also found out through our last activity that the weight of this volume of water is 1 kilogram. So BF equal to the volume of water displaced, which is 1 kg, equal to 1 kg. Thus, we prove the law of buoyancy that says the buoyant force of an object is equal to the weight of the fluid displaced by the object. Archimedes' principle also works for partially immersed object. To prove it, you can try it on your own. This principle not only works for water, but it works for any fluid. Let's summarize all that we learned. Upward force is equal to the weight of the liquid displaced. Apparent weight is real weight, that is weight in air, minus appeared weight, that is weight in water. Loss of weight is real weight minus apparent weight. And buoyant force is density times volume times gravitational acceleration. Here's an assignment for you. I'm going to leave you with a question to solve independently. And the question is, an object with a mass of 5 kg, when completely immersed, displaces 1000 centimeter cube of water. You have to calculate two things. Number 1, what will be the volume of the object? And number 2, how much will be the apparent weight of the object in water? I hope this video helped you to understand the concept of Archimedes' principle.